Okay, so there's a chance that the 6-point question could be a 2-column proof like this, and even if it's not, it might be a small part of a 2-point or a 4-point question. It would be simpler than this, but this will be really good practice for either of those things. So this gives you quadrilateral ABCD. So what they're telling us is that this is a parallelogram. They're telling us that that's a parallelogram. That's the parallelogram symbol. If they're telling us it's a parallelogram, then we know opposite sides are congruent. We know opposite angles are congruent. There's a whole bunch of stuff about parallelograms that we know if they're telling us it's a parallelogram. They're also telling us that AF is congruent to CE. So this portion right here is congruent to that portion right there, which we ordinarily wouldn't know just by saying it's a parallelogram. It's ultimately asking us to prove that this FBED is a parallelogram in and of itself. So what we'll have to do, the plan moving forward, will be to prove this triangle congruent to this triangle. Once we do that, we'll know that this side is congruent to this side because of CPCTC. And then we're going to have to prove something about these sides at the very end, making it a parallelogram. So that's our whole idea. So if you haven't already, draw that shape. Pause the video if you need to, but draw that parallelogram, just how it looks there. Write down the givens and the proof, and then I'll start the proof from here. Don't forget the first thing you do is you write your givens. I'm not going to number anything because I don't want you to think that my number has to be the same as your number, and order really doesn't matter that much. But if you want to number them, you certainly can. So I'm going to say parallelogram ABCD exists, and that segment AF is congruent to segment CE, and that is given. So how many points do we have so far? 0. They don't give you anything for the given. We talked about that. But we now know opposite sides of a parallelogram are congruent, so that's going to happen later. We also know that opposite angles of a parallelogram are congruent. So if this thing is a parallelogram, we know that. And we also know this and this because it's given. So there's a lot we know in there already. So we already know a side. They told us the side right there, AF and CE. So I have that marked already on my picture. I'm also going to go ahead and say that AD, the left side, is congruent to BC. Probably should say CB. And that is because opposite sides of a parallelogram are congruent. So that's what I have marked here. Opposite sides of a parallelogram are congruent. That gives me another side. And then what we already talked about was this angle A and this angle C are congruent. Because opposite angles of a parallelogram are congruent as well. So you now have enough information to prove that this triangle right here is congruent to this triangle right here. So I'm going to say triangle ADF is congruent to triangle CBE. And what do we have here? Side, angle, side. In fact, I hadn't written down my last angle there, but remember, this order doesn't matter. But what I have here is side, angle, side is congruent to side, angle, side. Now that would be a really simple proof if it stopped there, but that is not what they asked me. So prove your triangles congruent first. Now you've already got quite a bit of partial credit because you've done a bunch of good things that are accurate. Remember, we're trying to prove that this parallelogram exists in the middle there. So now that I know the two triangles are congruent, I now know that this side and this side are congruent because they're in the triangles. So what I have here is DF is congruent to BE because corresponding parts of congruent triangles are congruent, CPCTC, because that's really just part of the two triangles. It's going to be sides of my parallelograms also, but it exists right now as just the third side of the triangle that we hadn't talked about yet. Okay, the problem is, in order to make this thing a parallelogram in here, we have half of it done. We have two sides of congruent, or two congruent sides right here, one pair. We need the other pair, which is right here. Now, we only have parts of that. But what we do know, remember, the original shape before we started was a parallelogram. We knew that those two sides were the same, but these two sides are the same also. So I'm going to go ahead and say AB is congruent to CD. Again, because opposite sides of a parallelogram are congruent. So I now know that, like I said, these two sides here are congruent. If I know that those entire sides are congruent, and I also know that this and this were originally congruent, then I can just subtract. If I subtract two congruent things from two congruent other things, then what's remaining has to be congruent. All right, so if I take the entire side right here and take away this, it's going to give me the same thing that if I subtract a congruent piece minus a congruent piece. You're going to get the same thing. So now I'm going to use these two lines sort of together. I'm going to say AB minus AF, right? AB minus AF equals FB. And I'm also going to say up here in the top row, CD minus CE. CD minus CE equals DE. I'm just going to call that subtraction. Just kind of tell me what you did. Now, if you had two things that were already congruent minus two things that were already congruent, you're going to have congruent things. So now I'm going to say FB is congruent to DE because of segment subtraction postulate. Now that I have FB congruent to DE, that is my other pair of congruent sides in a parallelogram. So now I have a parallelogram because I have two pair of congruent sides. So I'm going to go ahead and write my prove line down here. Prove that FBED is a parallelogram. Parallelogram FBDE. Actually, I wrote that backwards. It's ED. FBED is a parallelogram because two pairs of sides are congruent. A lot to do there. That would be a 6-point proof in my mind. If you can get 6, outstanding. If you can get 5, outstanding. If you can get 2, 3, or 4 points, way better than 0 or 1. And that's the key to getting a lot of points on a Regents, is when they give you a big proof like this, don't go 0 for 6. Write down as much rational information as you can possibly think of. If you see congruent triangles, go after them. You don't have to see this totally clearly in order to get some decent credit on this. This could be the 6-point question. I'm kind of hoping that it's a coordinate geometry proof on a grid where we have to prove something's a parallelogram. Those tend to be easier, and that'll be my final screencast tomorrow morning. Hopefully you've been doing these, keeping them together, stapling, bringing them with you on Friday. If you haven't yet, go back and do them. They're all in Google Classroom. Be a great way to study.